Example number 4 here is going to be probably one of our most difficult U substitution type problems that we're going to have in this entire semester. And we'll see the reason for this right away. Let's take a look here at the integral that I'm working with. I have an x to the fifth times a 1 plus an x squared. Now, if I wanted to start making a selection here, one of the most common selections that people would make is to have u be the stuff that's under the radical. So if I was to do this, then you can start to see what's going to happen. My derivative here would end up just being a 2x. And of course that means that I would then say that du is going to be equal to 2x times dx. And here's immediately where I start to see the problem. Is that, well, I kind of have x to the fifth in here, right? So my derivative is partially in here, right? Like I could imagine rewriting this one more time as 1/2 du and then an x times a dx, so I just multiply both sides by a half. And in here, if I was to imagine rewriting this, I could imagine that I would rewrite this as an integral. I have a square root of u now. In place of one of the x's and the dx, I can put in a 1/2 in the du. But notice that I've only tackled one of the 5 x's that are sitting out there, so I'd still kind of be stuck with like x to the 4th power. And so I haven't, with this substitution, fully converted my integral into something with only u's. So this can be a moment where sometimes people will just be like, all right, scrap this and let's start over. But very interestingly here, I think that there's a way that I can get rid of this x to the 4th. Take a look. I'm going to go ahead and continue to work with this statement here in my substitution. Notice if I was to just subtract 1 to the other side, I could state that u minus 1 would have to be equal to x squared. And then, if I went just a little bit further, and I squared both sides, I could state that u minus 1 quantity squared would be equivalent to x to the 4th. And so if I was to go ahead and take this piece of information, this piece of information, and this piece of information kind of all at once, I think I could make a substitution. Let's see how this would work. I would have x to the 5th power, 1 plus x squared dx. I'll slowly change some things out. First, I'm going to rewrite this as x to the 4th power times x, and a 1 plus an x squared. So notice again here that when I start to make my replacements, in place of this x to the 4th right away, I can put in this quantity of u minus 1 all squared. In place of my x dx, I can put in a 1/2 and a du. The square root symbol hasn't gone anywhere, but underneath it, I've put in a u. I have transformed this completely into an integral with u's, but is it an easier integral to work with? Well, I actually think that this integral can be a bit easier, but it does require a bit more algebra. Notice here that I have a u minus 1 squared. I can pull my 1/2 out to the front, and I kind of have a u to the 1/2 power here. Again, remember I cannot take an antiderivative of each of the pieces in a product because that's not a derivative rule that we know from earlier in the semester. So instead what I'm going to do here is a whole bunch of algebra. I'm going to go ahead and actually multiply out this quantity, which would give me u squared minus 2u plus 1. And then I'm going to take this u to the 1/2 power and I'm going to distribute it in. So this is ultimately going to give me a 1/2 times the integral of, let's see, if I'm multiplying these together, I'm going to add the powers. So this is going to be u to the 5/2 minus 2u to the 3/2 plus u to the 1/2. I have all of this. But now I could recognize that if I distribute the 1/2 here, or sorry, if I don't distribute the 1/2, I can leave that on the outside, but I could just do the antiderivative now of each piece, because that's kind of just undoing the sum and difference rules for my derivatives. And I can tackle each piece with just a power rule in reverse. So notice that my antiderivative here would just look like, I would have the 1/2 on the outside, and then I would add 1 to the power and divide by the new power, or multiply by its reciprocal. Here, I would add 1 to the power, and then divide by the new power, or multiply by its reciprocal. And similarly, I just keep going down the line. Add 1 to the power, multiply by the reciprocal of that power. Okay, so I have this. Notice I could even start to simplify by distributing in my 1/2. I could rewrite this as, let's see, this would be 1/7 u to the 7/2. Multiplying into here would just leave me with, oops, it should be a minus. So I'll have a minus 2/5 u to the 5/2. And then when I distribute in here, I'm going to be left with a 1/3 u to the 3/2. And oops, it looks like I definitely forgot something here. I forgot to include a plus c on my antiderivative. Now, of course, when I take my 1/2 and I multiply it to that c, I'm just going to get a different constant, which I could still just call c, or you could call it c number 2, or however you want to note it. I just often just still refer to it as c. Now, this still isn't a final answer, because remember, the last thing that I'm going to do is replace all of my u's with what u was originally. So that was 1 plus x squared to the 7/2. Oops, and then a minus a 2/5, 1 plus x squared, and this would be to the 5/2, and then finally plus a 1/3, 1 plus x squared to the 3/2, and plus c. So I have a very, very complicated antiderivative here. And in fact, this one would be actually a little bit more difficult to actually go ahead and check, although it's still doable. I would just have to do some derivatives and then actually do a lot of factoring to try to get back down to this original form. So this is something to keep an eye out for. If I'm finding that I maybe am unable to find a substitution, I always end up having just like a little bit of extra stuff left, like this x to the 4th was left after this first line. Maybe there's some stuff I can do to rewrite my original u to get rid of the extra stuff like this x to the 4th that's hanging around. Again, these are the most challenging types of u substitution problems that we'll see this semester. And it's really going to be practice that's going to help you continue to improve and be able to spot problems like this and be able to kind of adapt to them as they come up. Now, the last example in this section is example number 5, and it comes in quite a long question. Notice here I have 6 different parts. It goes all the way down to part F. And these are all going to be questions that I'm going to leave for you to try to actually tackle on your own. Now, the solutions for these questions are posted up online in Blackboard, but I would ask you, before you go take a look at the worksheets, try these. These are meant to be kind of tailored to where you're at. They're going to slowly kind of increase in their difficulty, and so you can hopefully get a good set of practice here before you start taking a look at more complicated worksheets or homework questions. So go ahead, give that a try, and of course, if you're having any questions, if you're having any concerns, by all means, please, please, please let me know. We're going to be working on this topic of use substitution for quite a while because it is one of our more difficult topics in Calc 1, and it's certainly something that's important to master because it'll be knowledge that will be used very, very heavily, very immediately at the start of Calculus 2.